Parakai. Okay, looks like we are live right now. YouTube, let's go and check it out. Yeah, we are live. Okay. Hmm. So basically, today I'm going to be working on the thingy, Zion poster today. So completing that, we will move on towards the code and stuff. So for the Zion poster, I have like a small idea. We're gonna have this in the middle, have a bit of a glowy thingy behind it. Then we have three squares here and the QR code at the bottom. I have to move this a bit towards the up though. One sec. Get back. So first thing is I found a background here online. So let me like use this as a reference first. Hopefully, if we get it like after this, we can use this as a good reference though. That's what I'm trying to say. I'll have to put this below all these. Not bad. Let me like add an effect or something. I'm begging you. Hands off, Gabriella. There's no like, no, there must be something like that though. Oh hell no. You're going back? How to get neon text in this? Okay, yeah. Okay, what's the tutorial? Neon and Figma tutorial. Never mind. Me just get a YouTube tutorial. So I get it that. Fill it with the color. We added auto layout to it, so let me also do that. Yeah, I'll have to remove the padding then. Okay. This drop shadow should also work perfectly fine according to me. Let me just go here again. We'll close Fallout here and yeah. Padding has been removed, I think. Like we'll have to fill it out. This so can this be a bit more obvious, man? Oh yeah. This is gonna work out well, I think. Going cyan and then what is that? Frame one. Huh? Looks like we lost some stuff there. Okay. Let me move it around here. Reduce the stroke to like 0.03. Put this at the bottom for now. We'll move this to the actual frame. Copy this font here. Like, let me just copy the whole thing. Change the size here. No. One second. Might as well make these a bit bigger then. One second, guys. One second, guys. I'll be back. Let me just complete this. Sorry, guys. I'm back. So, I was thinking about making like adding a bit of font or text though. I have to somehow adjust the place. I mean space. Let's keep this in the middle though because that's what really matters. I'll be adding like a bit of text here and also here. Okay. So now that we have that thing figured out, let me. I think I might be working on my firmware just right now. Oh wait. Before I start with my like uh that stuff firmware, I have to start off with my schematic. I have to see like what is connected to what, right? So let me just like have a small look at it again. I'm gonna be using anti-gravity. I mean, not like that, but still, trust. Okay. Me make make something here. New. What can I make it? Let's make it Python. So file, new window, open folder, desktop, Maldeck, select folder. Okay. Terminal, new terminal. Code. Looks like it opened this. Okay. I mean, even this is good. So let me first like analyze my schematic properly. I'll note all the like stuff down. So actually getting into serious business now. Let's also take like a small screenshot of this. Oh, huh? Wait. I think I found a big loophole. What do you mean the schematic editor still has this then? Removed this long ago, ages ago. Oh, let me go back. No, man, that was something else. I removed this. Okay. So, put it there. Let me like note down all these connections in my notebook IRL. Okay, let's start off right now. Um, Okay. MicroPython documentation. Pretty sure we should be like importing what else we importing? Oh yeah, from Adafruit we have to import these keyboards, so like those are like completely important. We cannot skip those, and like these are the basic ones. And pretty sure from a rotary encoder we need a rotary IO, so we'll import that as well. So let's start importing though. We have to start off with importing time first. So import. Let's go with like time. Okay. Now import. What else? We have a board. So import bus IO. So like it does not okay, it does not recognize them. That's bad. So okay. What else can we import? Uh, yeah, ESP HID. Hmm. I have coded Arduino in C++ before, but this is my first time like actually using Python for Raspberry Pi. Let me bring my keyboard up to the table. Circuit Python. So use import rotary IO. Incremental encoder class we can access. So yep, that's it. That's good actually. And actually, NeoPixel is also important. That's what I found today in the morning. NeoPixel. Yep. Okay. And let's also have like NeoPixel. We added time. We added board. We have bus IO, rotary IO. We have keypad. Actually, we have to import keypad. We have like how many imports now? 2, 3, 4, 5, 6, 7, 8, 9, 10. Hmm. What else can we need for what else do we have? PWIMO. Let's use PWMIO then. Sorry, PWMIO. Save this currently. Compatibility layer. We already have bus digital IO and bus IO. So mm, so first thing I'm talking, I think we should start off with like the USB HID, you know, setup. We will leave a bit more space for the imports. Maybe I'm missing a few. Pretty sure I'm missing a few from Adafruit though, because they make a lot of stuff for like, yeah. So let's start off with the USB HID. Um, okay, this is good. Let's keep it like this. So yeah, I mean, this is basically telling me what to do. So let me just make it like a bit shorter then. KBD is equal to USB HID devices. Okay, via function. Okay. Hmm. So like now let we have to do with consumer control. Oh yeah, that's what I'm missing. Consumer control is what I was missing for so long. Um. Oh yeah, it's the same thing. I have to type it by myself or else it's gonna be AI. Sorry. Pretty sure the next one is gonna be like consumer control code. That's it. So okay, all that. So now we can work with consumer control. We have to assign a variable. So HAD setup. I'm pretty sure like that's enough. We have a so let's keep these in mind though. KVD and CCR are variables. Kept that in mind. Okay. What else we have? Switch matrix. Pin setup. Pin setup is actually should be done in the first. Yeah, I should have done that before. So basically, like it's the same thing as switch matrix setup anyway. Actually, let's like number these so that we won't get lost. No, not NeoPixel. First, let's do like a 3 by 3 matrix setup. Um, we'll the diodes are from rows to columns. So let's make it like row pins and then column pins. Okay, row pins and column pins will be good. So that's easy. Row pins are what? GPIO 10, GPIO 01, GPIO. Huh? Oh, sorry, what are rows again? um, wait. Uh, uh, I'm pretty sure we can start off with something like what was I going to do right now? Set up the switch matrix. Okay. Diodes are from rows to columns. So diode. Oh, cathode anode. That's like quite. Yeah. So now let's make a row pins. Now this is where you have to refer a KiCad schematic and write code. Me like look at like past microcontroller code, so macro board. Me a search macro board. Using something else, I guess. He's doing it like this. I'm gonna do it using like hmm. So these are like different approaches which you're doing here. I'll be back in a second, guys. Like looking the this code, the logic, RGB and all he's using correct. Falling down reminds me of drowning, so 0, 0, 0, 1 and 0, 2 looks like that. Uh, 0, 1 and then okay, so looks like we're done with assigning those. Sorry, I'm lagging a bit. It's 12, 14 and 15. What made me write 10, 11? Okay. It's 12, 14 and 15. So GP 12. It's actually 0, 09. Actually, no, it's correct. Uh, hmm, 0, 09, 10 and 11. Oh, I was actually right. Well, I'm kind of hallucinating right now then. No, looks like we're done with that. Hmm. So let's define the keyboard matrix now. Uh, opens or something. So like, let's make it keys then. Row pins is equal to row pins, column pins is equal to col pins. So let's make it something like this. Then we have column. Hmm. Anodes is basically rows, so let's make it. So let's keep it like this for now. Let's make the key map now. Um, hmm. Yeah, what am I supposed to do after this, bro? I'm pretty sure. Let me just name it like anything random as well. So like, let's just follow this. FK Cody. Smell like actually. Let's add a comment here. Oh yeah, sorry. This is Python. Uh, be row 0 actually. Done with this. Okay, that's good. So let's just use the rotary IO library this time. It's gonna be pretty straightforward, I guess. So let's make it encoder. Pretty sure it's only gonna be incrementing though, so not gonna be much of a deal for me. Try incremental. Uh, GPO3. Was it GPO3 again? What in the world is this? There are two grounds here. Why is there another ground going from here then? Okay, let's see. Basically, we're supposed to be connecting it to GPO3 and GPO4 first though. Yep. Let's make it like yep. Uh, rotary encoder incremental. GPO3 and GPO4 only. Looks like we had an extra. Pretty sure that works. supposed to work though. That's the thing about Python. It's quite simple to decode. Encoder, what else can we do with encoder? Uh, so let me try like, oh, you have to put a digital in out, right? Uh, one sec, let me. Hmm. Oh, are all three supposed to be connected to GPIO control? Shit, I think I messed up. I'll have to redo the whole like thing again if I did this wrong. I have two things connected to ground. I'm not sure if that's supposed to be correct. Is W1 rotary encoder switch? Mm. I do have three pins connected to let me do this again. I'm supposed to go to the VCC. You need a VCC to run this. Oh yeah, I'm very much cooked here. Let me think about it for a second because I'm pretty sure I did not do it that stupidly when I did it for the first time. Actually, I'm pretty sure it's correct. So B and A are like both going there. Okay then. Let's continue doing this then. Um, think we got all that right. So you're gonna go back to like coding now. The panic attack is gone. So, hmm. OT encoder. So we were currently in the last position. Let's go to encoder button now. Encoder button will go to digital IO. Hmm. Hmm. Okay. Now, like the button direction. Pretty sure this is like basically guiding me. So, input, yep, input will be doing well. And lastly, encoder button pull. That's easy. So uh, like pretty sure the rotary encoder logic is done for now. That was only 5 lines of code. Wow. So let's make the underglow setup now. NeoPixel setup. So number of pixels first. Let's define that. because this is what is gonna give us the underglow, which is gonna make the board look a bit cool. Hmm. So now, yeah, it's basically telling us the next thing to do, man. This is like not very much fun. Is equal to 9. Yeah. But let's not keep it at 0.3 instead of 0.2. Then let's not auto right. Add a full option. Most people don't know about this. I was like researching about it yesterday after I was like when I was in bed sleeping at 1 o'clock. So a fill option will actually make it like a good a predefined color. So let's start off with deep purple. What's the deep purple code again? Um, let's close all these tabs. So that's a lot of tabs. Like huh? 800120 is what I remember using for my poster. So let's use the like same thing here. Let me just check though. 800120. No, not color conversion. Let me just see the color, bro. Oh yeah, it shows purple here, so pretty sure that's my bad. Pixel show, and I'm pretty sure that's we are done with the NeoPixel setup as well. Okay, so we are done with the switch matrix key map. We're done with the rotary encoder. We're done with the RGB lights. What else do we have? We have the buzzer. My bad, I forgot. Main loop already? No, no. We have like buzzer. Then we also have like I don't even know. I have a lot of stuff. Hmm. How long have you been streaming for? 1 hour 70 minutes. I'm gonna like complete this code in like hopefully the next 45 minutes. So I'm back. Let me do the buzzer thing. Because the older display thing will pretty sure it will take me some time. Um, 5 is the buzzer. Buzzer setup sounds nice. So, oh, this is exactly what we want. How does VS Code automatically know what I want to write for the next line? Like, have people already made these programs before or something? PWMIO dot PWM out, pretty sure. Yep. Go look at our connections now. Here it's like kept it at 19 or something. Yep, GPIO 19. So GP, yeah, board. GP 19 has been assigned. Let's make a variable frequency actually. I wanted to play some Mario music on it later, so we'll look at that part later, but let's just keep this true for now so that we can like change stuff. And the duty cycle actually we could have done it in the first statement, but we'll do it in the second one because I don't want to make it complex. So let's make it like buzzer duty cycle or something. Yeah, duty cycle. So basically it's off by default, I guess. Pretty sure it should be like that normally itself. I did not have to do that. Hmm. Excuse me. Okay. Buses use pin value. Passive buses use frequency. Okay. We have like a buzzer which I think vibrates. Uh, um, we'll define a beep for now though. Beep. Define beep. With like frequency and duration. Yes. Buzzer frequency is equal to. No, no, I did not mean to copy the whole code. That's gonna be getting me eliminated. I mean, it's a hardware hackathon, but still, software counts. So that's frequency. Yeah, frequency there. Duty cycle should be. Yeah, we'll keep it half. Let's not explode the buzzer just yet. Yeah, just yet, I mean. Hmm. So it'll stop in duration, and duration is actually after this we'll make the buzzer duty cycle go to 0 first. That logic has been built, okay. So whenever it runs first, let's make it yeah, let's make it boot. Oh yeah, it already shows that. 0.2 actually. Yep. Let's add a label for that. Yep. So boot beep. That would sound cool. Boot beep. Wait, is someone watching my stream right now? Pretty sure no. Day, how many hours then? Shubham, day. Bro. Valbox, bro. Hi. I did not even see that people are typing here. My mic is low. I can't hear shit. Oh, hello there. When did this stuff happen, man? Yeah, hello, hi. Volume mixer. What is my headphone anyway? Like, so no way to make it go higher. That's the like highest thing I have. So yeah, no, I almost accidentally shut down my streams. So OLED setup is the main thing for now. This is gonna take me a while. Uh, why does it say optional? It's not optional at all. That's like a main part of my project. So, we'll go here, but it's not included in this snippet. Huh? Uh, Actually, we'll keep this for later when we get our board so that we'll be actually accurately be able to. Hi in Windows. You do Windows. I'll do it later, man. Whoever is watching my stream. So, main event loop is the main thing here. We'll skip the OLED display for now. We'll keep a bit of space there. So, while true. Main thing in Python, while true. It's gonna be a loop for now. So, that is a big script which is already ready. So, let's actually read the main. We'll number it. Okay. We'll get it from the events function. So if the event is pretty sure, like a key switch is usually key index event dot key underscore number. Okay. So let's go if event mm, actually no, I think I'm falling for the same logic again. What can I do here? Yeah, if even press that will be working like a charm. Yep, okay. Come back to event inputs, so it should be around here. Hmm. It's actually print though. Printed somewhere for reference. Not pretty sure it will be in our console anyway, so key, let's add the key number. F string variable function. Everyone learns this. Number press. Key map, and then we go to key index, I think. Yep, we'll add it to a new key index or something. Key map, and then we will assign it to key index. That's key number anyway. Oh, okay. It should have been replaced there on top. Works well now, I think. This logic is done. Okay. So let's add this, and yep. Yeah, I have a good idea. So we can actually make the like when the key is pressed, we can turn the color below the switch to teal or something. That'll be like a cool logic. Yeah, that would be a cool logic. So let me implement that real quick. You can add this. Not light up. We'll make it like turn teal. Yep. I must have got it reviewed by now. Let me check the hardware channel. Yeah, I was checking it on my phone, but turn teal. Teal color code. All Out India is genuinely such a helpful channel, though I have to say. 128, 128. It's telling 255, 255. 0, 255, 255 color. Let me check it out. Uh, Yeah, that's good. So let's turn a tail here. Pixels key index is equal to 255. Yeah, do this logic like that, then the color will be remaining tail. We have to make a release color as well. So that should be like pixels release or something. Okay. Mm-hmm. So now else is also okay. X is equal to even plus. Okay. Okay. 80 0120. So let's copy the same one. Perfect. So pixel show. Pretty sure that will got it, get it correct. I got mentioned by Saket. So show. Pretty sure that should be done though. That's correct. Okay. So coming back here, assuming that we have done that correctly. Hopefully we have though. So actually let's not keep it else. Keep it if again. So even release or else even if it's not pressed, it's gonna change the color back to teal and bring it to purple. Release. This code will remain the same. Let's just remove the else part there. Reading the rotary encoder is part 2 of it. So let's make it play part 2. What library were we using for rotary encoder again? Rotary IO should be working. Mm, okay. What old is this? Okay. So let's remove this. You're still live, right? Yes. Enter, exit, position. Huh? Circuit Python instead of MicroPython. The nanometer both are connected there. Script rotary reset value set label. Okay. All you have to rotary encoder logic logged, and let me just check the pins again. BA and S1 are connected to GPIO pins, and S2 and C are both to ground peacefully. So ground is quite safe. If I change a connection now, I'll have to redo the whole PCB again. It'll take me like one extra hour. Skip that part, we'll somehow make up for that in the code. So keeping that in note, this has to be changed somehow. Change that in the code logic. Then we also have power conversion. This is unplugged right now. Still showing me the error here in ERC, but I ignored the test. Excursions, yes. Removed them because it was overreacting for me not using a power flag and it was not working. Probably that's gonna be the potential problem we're gonna have here. I'll have to redo the rotary encoder again, but how many hours have we been live for? 1 hour and 40 minutes. I'll take a break and then I'll come back. I'll fix the logic here and then, yeah, next stream I'll fix the logic here and complete the code. After that, the night will complete the design and get our GitHub readme done. We'll ship it within today. I have lots of time. 4 more hours will be enough.